Assalamualaikum and very good day to Dr. Jamil. We are from Group 1 and today we would like to present our assignment. So this is our group members which consists of 7 people. Amir Aiman, Amir Wafiq, Fauzan, Kirosha, Hani Hazikah, Alia Farhana and Hanis Farzana. So after we discuss together, the topic chosen is based on Lab 5, which is Filter Design and Application. My name is Hanis Farzana and I would like to present about Introduction. Introduction about Digital Filter Design. The purpose of filtering is to change the frequency of a signal. Filters are commonly used in many systems to remove noise from a signal. Analog filter and digital filter are the two major types of filters based on the type of signal they process. Analog filter are used to process continuous time analog signal. Digital filter, on the other hand, process sample discrete time signal. The design of digital filters requires the use of both frequency domain and time domain technique. This is due to the fact that filter specifications are frequently specified in the frequency domain and implemented in the time domain using different equations. The Z transform and discrete time frequency transform DTFT are common tools for frequency domain analysis of filter. So this is the advantages digital filter. First one is the performance of the digital filter does not vary with environmental parameters. Second, digital filter is easily designed, tested and implemented on a general purpose computer or workstation. Third, it is used where the use of an analog system is impractical due to its operating level is at low frequency. This is the disadvantages digital filter. First one is quantization noise is present. The bandwidth of the digital filter is much lower than an analog filter. It required more design and development time compared to an analog filter. This is type of digital filter. There is two major types of digital filter, which is FIR and IIR. FIR is stand for finite impulse response and IIR is stand for infinite impulse response. For FIR, there is 4 types, which is Type 1, symmetric sequence of odd length. Type 2, symmetric sequence of even length. Type 3, anti-symmetric sequence of odd length. Type 4 is anti-symmetric sequence of even length. For IIR, there is Butterworth filter, Chebyshev filter, Chebyshev 2 filter, also known as inverse Chebyshev and type 2 Chebyshev filters, elliptic filters, also known as Trawer filter, and Bessel filters.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fauzan Faruddin and today I will be explaining our objective for this assignment. So there are 4 objectives for this assignment, which is the first one. Our objective is to identify steps that are needed to be taken on designing a filter. There are several basic steps or configuration that needed to be taken into account before and during designing a filter. For example, before starting a filter design, we need to carefully characterize and identify signals that we use to alter. This will allow us to determine the filter configuration that we need to use. And after that, our other objective is to learn about the capabilities of filters. Different types of filters have their own capabilities in which gives an expected output that meets filtering requirement. For example, the low-pass filter helps us in smoothing the filters. Meanwhile, high-pass filter capable of sharpening mask filter. And then, Bandpass filter allow us to block signal outside the specified band. And finally, bandstop blocks signal inside certain specified band. Other than that, our third objective for this assignment is to understand the various filters and its own respective function. Each of the filters have their own function that help us in altering signal as we want. Different filters have different function. For example, low-pass filter allows passing only low-frequency details while attenuates the high-frequency details, while high-pass filter allows passing only high-frequency details and attenuates the low-frequency detail instead. After that, bandpass filter only allows signals within a certain band to pass and attenuates the frequency below a threshold and above a threshold. And bandstop filters attenuates signal in range of a specified frequency and allows frequency below a certain threshold and above a certain threshold to pass. And finally, our fourth objective is to utilize the filters properly and correctly. Using filters properly is very important to give out a perfect output. Hence, it is important to know how filters actually work. By using it properly, we will get an output that meets our expectation as desired.
Assalamualaikum and hi, my name is Alia Farahana binti Nur Afandi and I'm from BEC S1/1. Today I'm going to present to you about the peak notch filter design. We know that the notch peak filter block filters each channel of the input signal over time using a specific center frequency and specific bandwidth. This notch filter design is a combination of low pass and high pass filter, which is similar to the band pass filter design, except it is connected in the parallel connection instead of a cascading connection. So based from the lab 5 lab sheet, we use the mystery signal file, multimedia file, and also the notch filter block. We also have spectrum analyzer, which is this one and this one, and then the switch, and we use the audio device writer. So when we run this Simulink, so from this output, the spectrum analyzer is the before filter and spectrum analyzer 1 is the after filter. From this we can see it is noticeable that in before filter there are a peak frequency present in the spectrum. However, in after there's no peak frequency because the peak frequency were removed. So we can conclude that the notch filter remove the peak frequency at -7 kHz and 7 kHz. So for the assignment, we use the same sound but using the peak and notch filter block. This one. So for this Simulink, we just need to connect. I just connect the notch switch at the spectrum analyzer 1 and the manual switch, and then when we run, so from the result of this assignment Simulink, we can see that before and after output of using notch filter, we can see that it suppresses the noise at a specific frequency. So we can see that from the frequency -6 and the 6 kHz, it is being cut off or removed of the sound wave. Here and also then we use we connect to the pitch switch and then we run. So for the peak filter, the uses for this is it enhances the signal at a particular frequency. We know that it will remove. We know that the sound will be removed at certain frequency. So for this filter, peak filter, the frequency of from -6 to -6 kilohertz, the peak signal are being enhanced and cut off.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Fiazat from BEC section 1G1. So today I would like to present our assignment. So firstly we choose the assignment from Lab 5. So this is the first task that I choose, which is it is from task 3. So here we use my low pass as a filter. So we can see this is coding for my low pass. So we use pass band is 4000 Hz. Next we use stop band for 500 Hz. And then we use sampling frequency 22,050 Hz. So next we run the simulation first to see the output. Okay, if you can see the left side is before filter and the right side is after filter. So for the before filter, you can see that sound has a noise. And then after we use my low pass filter, you can see that the noise has been reduced. So we cannot see the noise here. That is from Lab 5. Then after that I changed it to my notch 1. Okay, for my notch 1, this is the coding. Okay, for the my notch 1, filter which is n equal to frequency f0 equal to 7.35 kHz, and sampling frequency is same with my low pass, which is 22,050 Hz. Then simulating to see different between the filter. So same with before this, the left side is before filter and the right side is after filter. We can see that before filter have noise and if after filter don't have noise. Okay, I show it again to see how the noise has been removed. So you can see that the noise has been removed slowly from the sound. Lastly, the sound don't have a noise. So the function of notch is the notch is to remove the noise. Okay. Next, I use Dash 5 from Lab 5. Okay, from the lab, we use low pass and design method is FIR. So if you can see, the left side is before filter and the right side is after filter. So before filter, same with before this, we can see that the sound have noise, but for the after filter, you can see that the noise has been reduced from the sound before. So you can see the wave has reduced for the noise. So next, I changed it to IRR, but the left side is before filter and the right side is after filter. So same with before this. Before filter have noise, but after we use IRR for afterward filter, you can see that the noise has been removed from the sound. Okay, the function for Butterworth is Butterworth filter is designed to have as flat a frequency response as possible in the pass band. So this is the output for after we use Butterworth filter. That's all from me. Thank you.
Okay, for discussion, what we understand that filter design can be applied in variety of ways, including analog and digital and method. Analog filter design involves the use of physical components such as resistor, capacitor to produce the filter, whereas digital filter can require the use of mathematical algorithm. So the digital filter are more adaptable and can be readily customized and incorporated in the software. The method of the filter design used will be determined by the application specific needs and the intended outputs. So overall, the filter are required in a wide range of applications such as including power supplies, audio electronics, and radio communication. There are various filter design approach exist that including the Butterworth, Chebyshev, and applicative filter design method. This method has advantage and disadvantage. With the Butterworth method, is offering a smooth roll off but with the less step of transition compared to the Chebyshev method, providing a higher roll off but with no ripples in passband. The project actually focused on the use of design of the filter, which is focusing on the use of the MATLAB as a tool for designing and simulating filter, which is a specific impulse and frequency response. In a variety of applications, the filter are used to remove undesirable noise or interference from the signal. The process can be used to design the filter and adapt to the application-specific requirement and restriction, and the filter is tested to ensure its performance. Discussing from the task, we are required to create a filter circuit using Prequad filter design. This filter design allows to customize low pass, high pass, and any desired frequency shaping of the signal. Each Prequad filter has an all-pass frequency response by default, which is a frequency response with a flat gain of 0 dB. We can clearly distinguish between the before and after filter in this world. The after filter spectrum analyzer frequency are more uniform than those before filter.
For this task, we are are required to use the peak notch filter block. The notch filter's default value is used instead of the quick filter's default setting value for the parameter setting. Next, we click the View Filter Response button. In addition, we switch the output from bit and notch to notch before running the model. The difference between the unfiltered and filtered version is that unfiltered version has noise, whereas the filtered version does not have noise in the output waveform due to filtering. Filtered waveform is significantly smoother than waveform before filtering. This particular task requires the use of the digital filter design block. Before we run the model, make sure that the low and notch filters have the settings that are displayed in the result, and that you click the design filter. An upper waveform with noise cancellation is the waveform of the output for an unfiltered signal, and it is the waveform that contains the noise. When compared to the filtered version of the identical waveform, the unfiltered version of the waveform has a more jagged appearance.
Hi, I'm Kiyoshi Macha. My entry number is B0820102222. Today I'm going to explain about the conclusion for our assignment. As the conclusion for our assignment, we are able to understand the big wide filter, big notch filter block, digital filter design block, and apply in MATLAB Simulate. The big wide filter block independently filters each channels of the input signal with the specified quadratic infinite impulse response, which is IIR filter. When you specify the filter coefficients in the dialog box, the block implements static filter with fixed coefficients. The next one is the notch peak filter block. The notch peak filter block filters each channel of the input signal over time using a specified center frequency and 3 dB bandwidth. This block offers tunable filter design parameters which enable you to tune the filter characteristic while the simulation is running. And then the digital filter design block used to design and implement a digital filter. The filter you design can filter single channel or multi-channel signals. Other than that, we can acquire the capability of applying filters to meet certain filtering requirements. And then lastly, at the end of this assignment, we are able to understand the functions of the filter design and applications.